Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the SFML series. I hope you've been enjoying the series, and just as a recap, here's what we made last time. We made this little screensaver effect with a bunch of game entities moving around, and started building a game entity class with a component system. So this is sort of a entity component system in the works here. Now, before we progress forward with this, you might notice there are, well, a lot of these little ghosts here, a lot of these game entities. And eventually we're going to have to manage them in some way. So what I want to do in this lesson today is build a entity manager. That is one place where we'll create all of our game entities and have them updating, rendering, and so on, so you don't have to manage that part. And eventually, if you'd like, you could build a data structure on top of this entity manager, things like scene trees and so on, to make this a optimized data structure and so on. So this general idea can be evolved, but let me show you the basics in this lesson. So let's go ahead and get started. So again, what we're going to be building here is an entity manager to manage all of our ghosts here. So I'm going to go ahead and just close the screen here and just show you the basic idea of an entity manager. Now, the basic idea is, again, we're going to have one class or one location, and we'll call it entity manager here. Entity manager. And in this class, this is going to have functions such as create entity. And this is going to be following what's known as a factory method. That is, we're going to have one function that returns a new object that's been created. This is a great way to also control how objects are being created and also log, for instance, what types of objects are being created. So factories are a useful design pattern for that. I'll link to a video below if you want to see the factory method itself without any of the SFML stuff, so you can learn about that. But that's the basic idea. And then we need to hold all of these entities somewhere. So we've got a few different ideas, but we're going to need some sort of container here. Container, and I'll sort of abbreviate, of our entities. So this will be some sort of holding data structure for us. So at least initially, what I'm thinking about having is an unordered map, because we can do O of 1 lookup to retrieve entities from our entity manager, as well as it's a easy enough data structure to iterate through using a C++ iterator, so we can render all of our entities, which is the next part. So we're going to need to be able to render all of our entities at one time. And we might have associated methods or member functions for things like updating or drawing and so on for each of our different components in our entity manager. So with that little sketch here, let's go ahead and create our entity manager. And just to keep folks who might be joining the series up to date, or if you've been following along and need a reminder since the last lesson, here's what we've created so far. We have, again, a game entity interface, a component, which serves as a base class for any of the components in our sprite component here. So let's just go ahead and look at game entity very quickly. And since the last lesson, I've broken these up into implementation and header files. So if I open up in the include directory, game entity, we can go ahead and just have a quick look at this to remind ourselves what's going on. And this is where we were creating the ghosts and so on and moving them around. Now, again, eventually we'll want to add different types of components, things like a transform component and so on. But for now, we're just going to start with the entity manager at this point. So again, you can see we had some functions here for adding specific components, and then ultimately rendering all of the components that belong to one entity. And for now, there's typically a one-to-one, one sprite T2 component per game entity, although that doesn't have to be the case. You could have multiple if you like. And then we had a little hard-coded thing, and that was determining what the directions are. So eventually we'll want to get rid of this. Okay, so that's just a little refresher on the game entity. Those are the things that we're going to be creating in our entity manager. So let's go ahead and dive in. And what I'm going to do is go ahead and create a new file here, game, or let's call this, again, entity manager, HPP. So I'll go ahead and set up my header guards, entity manager, HPP, and define, and endif. And let's go ahead and just create this class here, the entity manager. Now we've got a few different choices here for things that we might want to do here. Because this is specifically for game entities, we could make this a sort of interface, because we might want to manage other things that might be different, like sound manager or other resources that we might come up with that are somewhat different. Again, for now, I'm just going to keep things simple and just have this as a single entity manager in our game here. The other design decision that we have to make is whether or not we would want to make this a singleton, for instance, to just have one place where we are instantiating and creating all of our objects. So oftentimes factories you might see as singletons. They don't have to be, but that means we'll just have to pass this entity manager around if it's going to be used in other data structures. I'm going to opt in this lesson to make this a singleton. So let me go ahead and just add that to our little design diagram here. So if I point to here, this will be a singleton. There's a lot of debate about whether this is a good or a bad thing. For a small project, this is probably fine for learning purposes. And if we have a need, we can get rid of the singleton pattern here. Okay, so let me go ahead and just leave this on the side here. And because this is going to be a singleton, what this means is our private member functions, so let me go ahead and label these here, will be the constructor, because we will not be allowed to instantiate a constructor, as well as the destructor. Essentially, this singleton will live once it's been instantiated once for the duration of our program. So that's sort of one of the cons, actually, of this entity manager as a singleton, but that's okay. So this is a singleton for now until we decide otherwise or have a greater use case in our architecture. This also will make use of the factory method pattern. Okay. So with that said, let's go ahead and start sketching out some of the things that we'd like to do in our entity manager. Now, as I mentioned before, we're going to need to be able to hold all of our entities in some container data structure. And typically a unordered map is going to be a good data structure to do this in, because we can look up things by name, for instance, and then retrieve our entity. Okay, so that means we're going to need to include unordered map, as well as our game entity HPP. So again, if you need to see where that is, let's just list that out here. We have game entity HPP here. Okay, so with that map here, let's go ahead and do standard library, unordered map. And then what is the key value pair? So the key is what we're going to look up things, and the value is going to be the actual entity. And let's just call this for now entities. Okay, so the key again can be just some string. Recall that in our game entity class here, which let me go ahead and split the window so we can look at everything at once. And if I scroll down here, we'll see that all of our entities did have a name with them. Okay, so that's essentially going to be the key. And we forced this to be part of our constructor here. We only had one constructor, and every game entity had to have a name when it was constructed. So this means that we always have some key that we can use or reference and retrieve from an entity manager. And from an API design standpoint, this also sort of makes sense that we can just name some object, you know, ghost1, ghost2, enemy1, player1, or whatever, and just look up by string. Now, there could be more efficient ways to do this using integers, and we could sort of have mappings between strings to integers and so on to speed up lookups. But for now, this is fine. It's essentially using string lookups, which still will be O of 1, assuming we don't get any collisions and these kind of things in this unordered map data structure, which is some sort of hash table data structure. All right, so with that mouthful, that is our key, but what is our actual value here? So how are we going to instantiate game entities? Well, let's go ahead and just see how we did this in main for instantiating our entities. Well, in this case, we just had a bunch of entities that we were just putting on the stack, essentially, on this data structure here called entities. Now, there's two problems with this. The first is, well, all of these entities here are on the stack, and we only have limited stack space. So what happens if I do happen to need 5,000 or 10,000 entities in one scene or wanted to load that many? Now, there might be a better data structure to avoid that happening, but what I'm getting at here is stack space is limited. So that means we probably want things on the heap. And also, what we're going to eventually want here is the ability to, say, remove entities and delete them so that we don't need them anymore and remove them from our data structure. Or perhaps entities might share components, and an easier way to sort of share or manage sharing is with pointers here. So the entities that we're creating are going to be some resource that we instantiate at runtime. So anyway, let me just cut to the chase here and say that our value here is going to be a pointer to an entity here that we will allocate on the heap. Okay, now I'm going to do this in a particular way to just make things a little bit easier here. And we're going to use shared pointer here, and it's going to be a shared pointer to a game entity. So again, the idea here, or the rationale with using shared pointers, is it'll help make managing our lifetime a little bit easier of these entities as we create them. Now, again, we might want to think a little bit, and I'm including memory so that we have access to shared pointer here. We might want to think a little bit about if it could be unique pointer, should things be shared. I'm going to default to shared pointer. It's a little bit less to think about right now. And we eventually might want entities to be shared or sort of referencing each other later on. That is a possibility in a sort of gaming space here. Okay, so this is, again, our container structure. Some of you folks might just opt to use something like a vector and then just have indexes into your game entities and push back new items into a vector. That's fine in a sense if we're just doing a sort of small project. So, anything could be fine. Or there's a lot of different strategies here, I should say. Okay, so what we're going to want to do now is actually instantiate an instance of our entity manager. And typically in a singleton type of pattern, the way that we do this is we create some sort of instance function that will retrieve the one single instance of our entity manager. So let me go ahead and write this function here. So it's going to return a reference to the one and only entity manager that exists. And I'm just going to call this instance. And because this is a singleton class, we're going to make this a static function here, and that's it. So essentially what this is going to do is we'll have another static here, entity manager. That'll be a pointer to the one instance that exists. It'll get instantiated exactly one time. Static local variables here in C++ are guaranteed to be instantiated only once, even if you have multiple threads and other sort of weird scenarios that you could think about. So then otherwise, we just need to return this instance. And since this is a pointer, we are returning the dereferenced instance here. Okay, so this is what we have so far. Now we can actually get instances of our entities. Let's go ahead and briefly include this. So let me go to our main here, and let's include our entity manager header file. And I just want to see if I've made any silly mistakes here. So I'm going to rebuild. I have rebuilt since a build script here. So let me just show you what's there. So essentially, we're going to do a debug build in C++ 17, compile all of our source files, look in our include folder, output our program to the bin directory, and then link in all of our SFML files. So just a little heads up what's going on there. Okay, let's go ahead and build, see if I've made any mistakes. Miraculously none, or at least none that the compiler is giving me right now for our data structure here. Now I might also, since I am using string here, I am going to include string. Okay, so now the next thing to do is to start our factory. How can we create our entities here? So what I'm going to do is, well, the return, or what I'm generating from my factory, is a new entity here. So what we're going to have as the signature here is we're returning a new pointer to a game entity. And I'm just going to call this create entity. And well, what does our entity constructor need? A string. So whatever the name of the entity is. Okay, so let's go ahead and do that here. So we're going to have a shared pointer to some game entity. I'm going to call it a new entity. And that's going to equal a standard make shared. What type of pointer am I making? A game entity, and then the actual constructor name. Now again, we use make shared. It's a little bit more optimal in how we are constructing the entity, and it's also a little bit safer in the case that if we are throwing exceptions during the construction and so on, this will at least deallocate and so on. Okay, so that's what we are going to return, our new entity here. And let's go ahead and give this a compile, see if I did anything wrong, and so far so good. Okay, so let's go ahead and with that said, let's try to create a new entity with our entity manager here. So instead of, well, for now I'm going to leave this data structure here, but just to show how it's used, I have our entity manager. We're going to be calling the instance function here, and from that we will be calling create entity, and I'll just call this test here. And essentially, I just want to see if this compiles here. And because this create entity is returning a pointer to the entity, we need our standard shared pointer to a game entity, lowercase. Let's do game entity, and I'll just call this test object here. Okay, so let's go ahead and try to build that. And looks like it works. And I'll go ahead and just close this just for a moment so you can see on one line again what we are doing. We're creating our temporary test entity, and I'm just putting this on the stack right now. So we're essentially pointing to whatever this thing creates, then we could add components to it and so on. This object itself, when it's been created, well, we need to do one more step in our actual entity manager, and that is to insert it into our unordered map. Okay, so we're not quite done with that function yet. So let me go ahead and just split this here and open up our entity manager. Okay, so let me go ahead and just let's get rid of this window just so you can see everything. So again, the job is to create an entity, to create a new entity, and then add it to our container data structure. All right, and let me go ahead and just, for folks who maybe aren't as familiar with unordered maps, show you what we're going to do here. So I'll go ahead and open up CPP reference here in another window. And let's go ahead and look for the unordered map data structure, and we have all of our container data structures, and you can see that this is something in C++11. Now, again, I'm going to be inserting something or adding something new to this data structure, so there is a insert function here, and since C++17, we can use this here. Or as of 11, we can do insert, but we can also add nodes, I guess, in 17. So we can see a brief example if you need a refresher here. Basically, we are just going to insert a pair into our data structure. There's a couple different ways that we can do this. I'll just go ahead and use the standard make pair to do this. So I'm going to follow this example here. It's just a little bit more explicit what I'm doing, but you could use the shortcut notation if you like. Okay, so let me go ahead and close that out, and let's go ahead and, again, remember our entity data structure here, mentities. That's where we are storing everything. So create a new entity, store entity in our collection, so entities insert, and this is where we have the make pair here. And what is the pair? Well, again, this is our key value pair. So the name, that's our lookup, and the actual thing that we've created here, the new entity here. Okay. And then return our new entity to the client, whoever is calling this function here. Okay, so let's try to build that, see if I've made any silly errors. None to date, which is rare here. So we'll try to keep it going and have the perfect video with no syntax errors, but maybe I should make some so we can learn. Anyways, so now we should be having our create entity. And now the real test here is how can I, retrieve that entity and do something interesting with it, and then ultimately render all of our entities. Okay, so let's start with retrieve an entity. And well, what are we retrieving? So this will be some shared pointer to some game entity, and I'll just call this get entity, and that's fine here. I'll leave this as is. The actual entity, we're not modifying anything. This is just going to be a simple return. So I'm going to make this a const function. And well, we're returning some entity in our M entities collection. So this means a lookup in our map here. So M entities. And well, we're looking things up by name here. So we actually have to provide a name. And this should do the trick if it exists. If it doesn't exist, it's going to give us a null. So perhaps we could have some sort of error checking. For now, this is going to be sort of on the client here to just check that the entity that they retrieve was not null or does not exist. Okay, so that's how that will work here. So let's go ahead and compile as we add new things. And finally, our first mistake. And let's go ahead and look at this message here. I suspect we actually can't get away with the const here. It says error passing const unordered map, etc., as this argument discards this qualifier. Okay, so let me go ahead and just get rid of the const here and try to rebuild here. Okay, so that's okay. Because we're returning something that could be sort of modified as a pointer, I suspect that's what's going on here. Need to think about that a little bit, but now we'll retrieve the entity as shown, and the pressure is off. I can now make as many mistakes as I like. All right, so let's go ahead and write our next function here for rendering all of our entities. And you can give this sort of whatever name that you want, but basically the idea is we want to iterate through this entire collection and just update everything. Now, we also might want to have an update all or some other functions to iterate through everything. For now, let's just look at iterating through the actual map data structure. And I'm going to do this with a iterator in C++, so this might be something you need a refresher on. I'm going to use auto to make it a little bit more brief here, but we want our entities, which is our map, the beginning, and while that's not equal to the end, then we will iterate forward here and essentially call our render function on our entities. So how am I going to do this though from our map data structure? And it's probably worth again, just looking at that for a brief moment to see that it's a string for the key and the value is the actual entity. So this is the actual thing that we want to call render on. So as I'm retrieving all of these entities, what I'm really getting is an iterator to each of the sort of key value pairs. So I'm going to have an IT first, which is going to be the entity name and the actual value. So this would be just the game entity. So the entity itself, which is the second thing here. Okay. So with that said, let's just go ahead and, well, since we have the second, the value here, which is the entity itself, let's just go ahead and try to call render on it. Okay, and I actually don't need any temporary storage or anything for this, more so just to show you. So let's go ahead and try to see if that works. And of course, we're going to need the SF render window so that we know which entity we're rendering to. Let me go ahead and show this in case folks missed the previous lesson here on our game entity. And I will split this into a separate implementation file later. But the idea here is when we're rendering, we need to know what SFML window that we're rendering to. So we will have to match this signature here. Render window ref. And again, this is probably something that could be eliminated or only stored once in the entity manager, or per application, you just have one render window. Again, if you know that you're going to make a gaming application, then that probably makes sense, so you can optimize a little bit. But I'm making this much more general purpose. So we'll just pass in the ref here, and let's try to rebuild. And just a spelling mistake here. Should be IT++ here. So let me add a character here. All right. And I'll try to rebuild. And looks like we are good to go. So now we have an ability to, again, create entities, as shown here. We can retrieve our entities, and we can render them all. So let's refactor our main for just a moment to see if we can recreate the same screensaver effect. So I'm going to go ahead and open up, and I'll do this with a v-split, our main. And now we'll no longer create this vector of entities here, but rather in this loop here, when we create, well, however many entities we want, our 50 entities. And I'm going to name them as shown here, ghost plus standard to string I. And for each of these entities that we create here, the test entities, we're still going to be adding the sprite component. Now, since this is a pointer now, I need to use the arrow and so on. Okay. And that's it. I don't need to push back in any sort of data collection or anything. So now, instead of having this loop here for all of our entities, what I'm going to do is rather just call the render all function. Okay, so let's go ahead and this will handle all of the drawing. So for our entity manager, again, we will get the instance that we want, and then we'll just call render all. Okay, so let's go ahead and start with that, and then I'll revisit this movement here so we can talk about that here. And let's go ahead and just see if that builds. And oops, a few mistakes here. It looks like render all. Let's see. Again, I'm going to keep making this mistake here, where our window is the actual thing that we are drawing on. And now it compiles. So let's go ahead and run this and just see what we get here. So again, we get all of our ghosts. They're all rendering, but they are not all moving at this point here. So we still have to figure out the movement here. So what are our options here? Well, what we could do is iterate through each of our entities. Now, if you know this is a game, for instance, and we have the names of our entities, we know they're labeled ghost 1 through 50 here, or 0 through 49 here. And that's what I'm going to opt to do for now. So let me uncomment this. Here's how we, instead of creating our entities here, and I can actually show you, we're just going to get all of our entities here by name and then update them appropriately in a loop. So let's go ahead and close this out here. So from our entity manager, we will get the entity, and it'll be by name here. And that's what's going to go in our loop. And we know we have 50 here. Again, maybe we'd want to query in our entity manager how many exactly that we have, or some other data structure. But for now, we'll just get a pointer, shared pointer to the game entity. And let's just call this ent for short, ENT. We don't need to render them. but we do need to set all their positions and basically just change this to ent everywhere. And since this is a pointer, we need to use the arrow here. And it is a specific entity. Okay, so just bear with me as I'm doing this. And let me add a comment here so you can look at this. Retrieve each of our entities by their name. Update the entity positions. Okay, and then we'll just do this again, one thing at a time here. And I'll use some speed this up and delete a few of these things here. All right, so that looks like everything should be up to date here. And we're using our entity manager. So let's go ahead and give this a compile. Like cross our fingers, see if I made any mistakes. Yeah, of course, there's got to be one here. So made this a little bit, some leftovers here. And there we go. All right, let's try to give that a build. And looks like it builds. And now it is running and everything is going through our entity manager. So folks, just to recap what we've actually done here, I'll put up the diagram here and let's bring up the ghosts. We've built this entity manager where we can create entities and render them all in a single call. That makes things a lot cleaner, especially in the main CPP of our application. This loop is just sort of following the logic and it becomes a little bit easier to follow what's going on, as well as someone who would want to use this little game framework that we're creating, it becomes a lot easier to, again, follow. So with that said, folks, I hope you found this an interesting lesson. I hope this was useful to you and you're now sort of exposed to this idea of having an entity manager. Again, you can abstract different data structures on top of this, optimize away, or create other helpful functions. So in later lessons, you'll see me possibly add on to this and you'll understand what's going on. And again, this is a great place for doing optimizations and so on. So with that said, this is another monster lesson in terms of length and concepts learned. So please take your time to digest it. And if you have questions, go ahead and comment below and I'll try my best to answer them. And again, if you've been enjoying this SFML series, please go ahead and like and subscribe so you don't miss any of the future videos. And I'll look forward to seeing you folks in our future lessons. Take care, folks.